Hi, today we are going over section 5.2, which is combining functions algebraically. We also have notes we went over combining functions graphically. So for combining functions, we often refer to our combined form as p of x, q of x, h of x, d of x, and h of x. And our component functions are usually f of x and g of x. Sometimes we'll throw in a k of x in there as well. Now, often we'll use p of x for a product function, so f of x times g of x. D of x is often used for a difference function, so f of x minus g of x. Q of x is usually our quotient function, so f of x over g of x. Okay, so to solve these types of problems, we'll substitute f of x and g of x into a formula we're given. We'll then perform any mathematical operations that are required in that formula. Expand, simplify, collect right terms, and reduce the lowest terms if necessary. So for example, we're given h of x equals f of x plus g of x, and we want to determine the domain and range. And we're given f of x is x plus 2, while g of x is x. So we have our formula h of x is equal to f of x plus g of x. We'll substitute these in. So we have h of x is equal to f of x. So as f of x gets replaced with x plus 2. Plus g of x, or g of x gets replaced with x. So this is h of x is equal to x plus x is 2x plus 2. So we can see this is a linear function. So therefore we know its domain is all real numbers. And its range is also all real numbers. Next one, we have p of x is f of x times g of x, and we want to state the domain and range. And we once again have f of x is x plus 2, while g of x is x. So we have p of x equals f of x times g of x. So substitute in our whole function f of x for this. So that's equal x plus 2. I'm putting in brackets because I want to make sure I multiply this entire thing by what my g of x is. So times x. We'll multiply this out. So p of x is equal to x squared plus 2x. Now looking at this, we know this is a parabola. It has a vertex that has a y value of -1. So because it's a parabola, we know our domain is all real numbers. Meanwhile, its range would be y has to be equal or greater than -1. Okay, next example, we've got q of x is f of x divided by g of x, and we also want to state domain and range. And f of x in this case is square root of x, while g of x is x minus 2. So we have q of x equals f of x over g of x. So substituting values in, we have q of x is equal to the square root of x over x minus 2. Okay, so looking at this, we are going to have restrictions. So for one, we know that x has to be equal or greater than 0. But x also can't equal 2. Now to get our range on this, you may have to graph it out, and essentially y would be all real numbers. Next, we have finding f of x and g of x given a product function. So what we'll want to do is factor the product function they give us, and essentially one factor becomes f of x, while the other becomes g of x. So for example, we have p of x equals x squared minus 9, and we want to find f of x and g of x so that p of x equals f of x times g of x. So we've got p of x equals x squared minus 9. I recognize that that is a difference of squares, so that's x minus 3 times x plus 3. So therefore, I can say that one of these is f of x, all the other is g of x. It doesn't matter which one we label as each one. So we'd have f of x equals x minus 3, and g of x equals x plus 3. Like I mentioned, it'd also be correct if we had f of x is equal to x plus 3, while g of x was x minus 3. Finding f of x and g of x given a quotient function will have many possible answers. One thing to keep in mind, though, is we want to make sure that the equations we're utilizing have the same domain as the original equation we're given. So the domains of f of x and g of x must be the same as q of x. So if q of x is all real numbers, then these both have to be all real numbers as well. Example, given q of x equals x plus 1, find f of x and g of x so that q of x equals f of x over g of x. And in this case, we're given a domain of all real numbers. So we essentially know what q of x is, and we want to know what f of x and g of x are. So with this, what we essentially do is we choose a value of g of x, and then we've got our q of x. We can use those to solve for f of x. So we're given a domain in this case of x is all real numbers, which means we cannot have a non-permissible here. So for example, I might say that g of x is x squared plus 1. Now I know this has no non-permissibles because no matter what, when we square a value, we're not getting a negative out of it. So essentially, if we have all real numbers down here, we could put x squared plus any constant term that is positive. So I've chosen something for my g of x. Like I said, there's many possible answers. I just went with something simple. Now we want to solve for f of x. So what we'll do is just rearrange our q of x equation to get f of x on its own. So we'll multiply both sides by g of x. So essentially we have x squared plus 1 times x plus 1 equals f of x. And then we'd FOIL this up. So we have x cubed plus x squared plus x plus 1 equals f of x. So we now have our two functions. We've got our f of x and we have our g of x.